Now, the height field erode node really does deserve its own video because it's so important to the process and it has so many options for us to cover. I've went ahead and created this scene that has different options that have been highlighted on different nodes, just to make it easier for us to find out and talk about what each option is doing. We won't need to go into great detail on every single option because not every single option requires an explanation. Some are pretty obvious. I also don't want to spend any time here just reciting what you see in the help menus or when you hover over one of these settings, but instead take a look at what they do physically and how we can use them in our terrains. Okay, so the first thing I did after the last video was drop down a mask clear. This is just to make sure that we remove any of this leftover masking from the previous nodes, in this case from the terrace node. Now this height field here is a standard erode. There have been no changes applied to this one, and we will use this one as the control to compare the rest of the ones to. The first thing you'll notice is the colours on this guy, dictated by the visualization tab. We can compute the range, and this finds the lowest and the highest values. And we can also add in our own layers if we like, based on whichever attributes we have applied to the geometry. These guys here, sediment, water and debris, are all generated with the height field erode. Starting at the top, we have the reset simulation, which does what it says. But we also have the freeze frame option, which prevents Houdini from recomputing the erode whenever we change the frame. So what we can do is we can choose a frame which we like. In this case, I have chosen 18, and we can freeze it. So when we scrub through the timeline, it doesn't try and recreate this erode. So let's go through the main options one at a time. First up, we have the simple erode. Now, we also have the global erosion rate at the top, but there's no need to cover that, as it's just really a multiplier for everything we're about to do later. We can see the difference if we look at the hydro erosion as the first port of call, and we disable it. So we have the erodibility set to 0. All the erosion here is coming from the thermal erosion. And you can see that we start to lose some of the rivers that we have running down the side of these mountains. If we then go ahead and up this to 2, I'll recompute this range for consistency's sake. We get some more rivers running up and down the mountain. The thermal erosion set to 0 removes all of these bigger forms that affect the actual mountain shape. And of course, if we set it to 2, it increases it. 0. We also get a lot more debris when we talk about thermal erosion, as we have a lot more carry down into these valleys. If we set the hydro and the thermal both to 2, we will get both more erosion on the main shape and some more river shapes that run down the sides of our mountain. However, because we have more thermal erosion, it does start to eat a little into the hydro, so we don't get as many rivers as perhaps we would like. But we can change this a little later using another setting. With the cut angle, everything above what we set is affected by the erosion. So in this case, everything above 10% is affected by the erosion, and here everything above 70% is affected by the erosion, which of course means everything below 70% isn't, which is why you have a lot less compared to when setting the cut angle to something a bit lower. What this means in practice is we retain a lot of these harder shapes. Now, let's move on to the advanced tab.